Hi, I'm Lee Teschler with Design World magazine. I'm here with Mike Walker from TI, and Mike is going to tell us a little bit about TI's DLP technology and one of the more interesting applications for it. Mike, I think the people who know about DLP equate it with projection TV and projection images, but that's not what they use it for here. Tell us a little bit about how DLP actually works to get us started.
Absolutely. Yeah, so if you're very familiar, as you mentioned, with DLP, it's used in video display. At the core of that, there is a MEMS device that can move photons at a very, very high rate. And our group basically takes those MEMS devices and repurposes it into non-projection type of applications. So this ranges from 3D printing to PCB lithography, 3D scanning and measurement, and then most recently we just introduced a spectrometer that's based on this MEMS technology. And basically the core interesting thing about that is that we're creating the world's first very, very small spectrometer that goes in new spectroscopy infrared ranges that can never be achieved until now because of this MEMS technology.
So the MEMS device basically serves as a bunch of very, very, very tiny mirrors.
That's right. Yeah, it's at the core of this, there's a very, very small MEMS device. We have our whole portfolio over here that you can take a look at. And what we did is took the smallest available device and made an evaluation module. We're still in the primary business of selling the MEMS devices, but we purpose it into an evaluation module so that, given it's a new architecture in a long-standing spectroscopy industry, then customers can take it and evaluate, and we're able to offer a higher level of performance than a traditional architecture because we put light into a single point detector. That increases the performance over an array detector, and typically it'll take an order of magnitude of cost out of a similar instrument.
Great. That's interesting technology, Mike. Food is in the headlines right now, particularly bad food and spoiled food. That's one of the applications for the DLP technology. Can you tell us a little bit about that?
Absolutely. Yeah, so with spectroscopy that's been in the industry for a number of years, applications that we've seen are pharmaceutical medications, what people take into their body from a medication standpoint, skin care and health, as well as just looking at food. And so in our demo here, we show the fat content of chocolate. You can detect proteins, fats, sugar levels of various foods amongst various numbers of constituents. And so we have a demo today that shows fat content in chocolate, and basically that's done with our evaluation module. But what we do is work with a set of worldwide design houses that actually make instruments out of this. And our partner here, KS Technologies, is demonstrating today that this is a battery-powered spectrometer that basically allows you to put sensors throughout a big network, Bluetooth it into your cell phone or go directly up through Wi-Fi, and leverage the Internet of Things to have sensing throughout a factory or throughout the world to collect all the data into a centralized hub and then do the analytics on it. And so KST in their demo basically has multiple spectrometers that are doing constant scans. They developed a Bluetooth app that then Bluetooths that into a server, and the server does all the analytics.
I see. We've got kind of an interesting demo behind us, Mike. Why don't you take us through that?
Absolutely. So the demo behind us basically allows you to take a chocolate and place it on the window. We do a scan. Light is broadcast onto the chocolate, and then the DLP spectrometer looks at the response. So every material in the world has a unique fingerprint from a spectral response standpoint. And this is a spectral response, and then basically through chemometrics, this is outputting that this particular chocolate is dark chocolate, and it has 14 grams of fat contained into it. And as I mentioned, you can look at sugars, you can look at proteins and various aspects of food. And then if you look at the KST demo over here, again, they have 4 different spectrometers. Basically, they took our module and they're putting it into a production system and have integrated that with their software platform to do IoT analysis for network devices, basically.
Great. Well, interesting application, Mike. Thanks.
Thank you. Appreciate your time.